So this is going to be one of the more advanced tutorials you're going to see on this channel. We are back in Cinema 4D again, but we are not using the standard Cinema 4D renderer. We're using a third-party renderer called Octane, and this uses your graphics card to render instead of your CPU, and it's a really interesting render engine, and you can do some really cool stuff with it in Cinema 4D. Today we are going to be creating a sci-fi VJ loop, and there is a lot to cover in this one, so we're just going to jump in and see what we can come up with. Okay, so I actually recorded this tutorial twice before, and both times I messed up the audio. The first time the audio was just crazy. I was trying a new setup in a new location, and it just didn't work, and I didn't realize until it was too late. So I thought, okay, let me try again. And the second time there was just no audio at all, and you're actually seeing the recording when I try to edit it in Adobe Premiere. You can see here over an hour long of me talking and trying to teach you guys something, and the audio is just flat. There's nothing. So long story short, developing this tutorial has seen its fair share of twists and turns, but theoretically that should result in a better tutorial for you guys, because I have done this project so many times now. That's sort of the only silver lining to all of this, and the whole thing is kind of funny, but hey, I wasn't gonna let that stop me. And here we are in Cinema 4D, and this is what we are going to be creating. This is a slightly different version to the rendered animated one, but only in colors. Everything else is basically the same. Okay, so in Cinema, I'm going to start a new scene, and let's start by building the tunnel. And of course, we are going to be using Octane Render later at the end to do this kind of style. All right, but the beginning part, we are just going to be building the geometry. Okay, so I'm going to start with a tube, and let's set the orientation to Z+, so it's facing the correct way. And the rotation segments, we want to drop this down to 5, which is going to create this pentagonal tunnel shape. Okay, and I want to set the inner radius to 180, and perhaps more than that, actually, maybe 190, so that we have a thin outer wall like this here, and it's going to have a height of 240. Okay, so that's one section. We need to clone this into a tunnel, so I will get a SWIP helix spline here, and let's rotate it 180 degrees this way, so it faces into the Z direction. And I will set the height to 5,000. And let's set the end angle to half the default, which is 720. So let's set that to 360. And it starts over here on the right side, so we want to push it back to the middle. So set the position to -200 on X, and that brings it right back to the world center here. Now I can take this and a cloner to create the tunnel. So put the tube into the cloner and set the mode from linear to object, and the object is going to be our spline. And I think I want 20 clones to close up those gaps. So the way the looping is going to work is the first section of the tunnel here is going to be the same as the second section. And the way I did this was by taking this setup, so put this into a null, and then take this and get an instance object, and you see that nothing appears straight away. So tick render instance, and then now we have a copy of the original thing. And the great thing about this is whatever I do inside of this setup, like change the number of clones, it will automatically update the instance. And this is how we'll stay consistent across these two different sections. So the second section is just going to be moved back to here, and the position just needs to be 5,000, which means it starts right where the other one ends. Now, if I were to take the same helix, and this one is going to be for our camera, so I will call this helix C. Let's get a camera real quick and attach it to the helix. But before I do that, this needs to be twice as long as its original length so that we cover the double length we have created here. So let's just set this to 10,000 for the height, which means we also need to double the end angle. That's how many times it twists around. So let's set this to 720. And you will see it now runs parallel or on the same path as the original helix, except it's twice as long. So this is the helix for the camera, and that's just the one for the clones. And later on, you will see why we have set this up this way with two separate splines. It will all make sense. But for now, just do what I'm doing, and you'll be fine. Okay, so let's attach this to our camera with an align to spline tag, and let's load up the spline into this. And you can see we are now looking through the tunnel. Tick tangential here so that the camera orients correctly. And let's set our timeline to be 8 seconds, or if you work in frames, that's 240. And I will animate the position starting at 0, and at the end it's going to be just 50%, not 100. So we are only flying halfway down this tunnel we have created. So if I look at this from a distance and play it back, this is the result. Now we need some linear motion on this, so we have constant speed. So if I go to the timeline, let's just select the keyframes. You can see the ease in here and the ease out. Let's set that to be just linear, so we have a constant speed, which of course is critical for this to be able to loop like you see in the example. All right, and here you can see that everything loops perfectly and everything's all lined up. This is actually just an 8-second section looping over and over again, and I made it into a 30-second video in this example. So let's see how our scene compares so far. And my camera here is going to be 24mm, so it's going to be much wider to give this exaggerated motion effect. Okay, so at the end here you can see that there's a slight hitch and it doesn't loop quite perfectly. These two tunnels are misaligned at this point here. So what we have to do to fix this is in the cloner we can use the rail system to straighten these out and make sure that this section will be the same as the second part. So that just means copying the original helix. Let's call this one helix rail. So I'm just abbreviating here to speed things up. And this rail spline will be offset in its position slightly. So instead of -200, it's just going to be -199 instead. So we'll end up with two parallel splines running alongside each other, kind of like a railway track. So that's what this setup derives its name from. Okay, I will drag the rail spline into the rail link box, and as soon as I do that, you will see a shift in the way the clones are arranged. And it also means that this is now going to be perfectly lined up. So if you have that issue, that's how you fix that. There's another slight hitch there. That's because the splines simply don't have enough segments. So if I get the ones which are 5,000 centimeters long, I will set the subdivisions to be 500. And then the main one I will set to be 1,000 because it's, of course, twice as long. And this should smooth out the motion of the frame. So we end up with something like this. And this is now looping perfectly. Okay, but that's just the setup for the main tunnel walls. Of course, in our animation here, we have this character flying down the center of the tunnel. So let's set that up as well. And this is a free model which comes with Cinema 4D, so you won't need to source this from anywhere in particular. I will provide it for you. Okay, at the beginning of the frame here, if I were to simply attach the same null, the same tag that's on our camera to the man, you see that he just flies with the camera. The idea here is we want to offset this to be ahead of the camera so that we are looking at him instead of basically through him. Okay, so the setup for this is going to be inside of a null object. So let's put that in there. And this is where the tag will be applied onto, which means we just need to zero out the coordinates of the character model. And then on this align to spline tag, we'll change its name to be align to spline M for man or C for character. And if we open the timeline, we want to offset this by I believe just 2.5% should be enough. Can't quite remember, but let's try that. So 2.5% at the beginning, and that means at the end it would be 52.5%. So this will maintain the same distance from the camera position throughout this entire animation. So if I play this through, you can see this is working just fine. I think my camera might need to be wider. I might have been using 18, but I don't remember. This looks more correct though. Okay, so obviously he is not spinning around. And by the way, this was just a character in a falling position. If you position it upside down, you will see what I mean. So right now it looks like he is sitting, but if you do this, he is falling. So that's why I chose this pose, in case anybody was wondering. Let's make this spin around. I need a time effector because I don't want to animate this manually. So if I go to MoGraph, effector, and time, I can place this at the same level as the character model under this null. And in the deformer tab, let's set the deformation from off to be object, which means this will now affect this object. And it does this weird thing where it moves each separate part of the geometry as one thing, because this model, you can actually adjust the posing by yourself by just opening this up and changing these rotations and so on. So it's made up of these various pieces to make up the full character. And by default, the time effector will move them individually. So we need to connect them together before we start the setup for this to work properly, basically. So that's quite straightforward. We use the connect object. So very simple there. And bring this in here, put the character model inside of this, and just make sure that again, these values zeroed out by default. So do the same for the connect. And now this should be moving as one piece, and it is. Now for this to loop, you can only use certain numbers. You can see whatever the default is here works, and it loops from start to finish. So let's look at what that is. In the parameters, we're using 90 degrees, which means that if you divide this by 2, for example, and we get 45, this will also work and loop correctly. And that's what I want to use here. Let's have 45, 45, and 45 just to start with. And I think one of these needs to be negative. I'm trying to get the same type of animation I have in the example, so I think that's it actually. Spinning from right to left, depending on your perspective, and then the legs go down at one point like this, and I think that's the same type of motion I had in this example. And yeah, looks very similar. Okay, so just be careful what number you use here. If I tried 40 degrees, for example, that would not be looping correctly. So certain numbers will not work no matter how hard you try. And you see the glitch there. So it seems like multiples of 90, or if you keep dividing by 2 or timesing by 2, that number will work with this effect. Okay, the next thing is going to be the geometry for the lights in the tunnel. So this orange and I guess teal, bluish kind of color. The setup for this is going to take place inside of this same null, because we want the instance to automatically inherit the same options. And by the way, if you for whatever reason break this setup, you can always just drag this null back into the instance reference object over here, and it will work again. Okay, and let's call this cloner walls. Make a copy, cloner lights, and in this one the tube is going to be much smaller. And in fact, it's not going to be a tube at all, because if you take a look at this scene, the lights do this thing where they turn on and off, revealing only parts of the pentagonal light shape. So on this frame, for example, you can see that the 2 lights up here are turned on, and then there's nothing here, and then just the one down here is lit up. And this is the animation I have going on across this light setup, where they're constantly changing their arrangement. So this means that these actually need to be individual pieces that we can control in this manner. So if I take the tube and take it out of here, I want to solo this cloner right now. So we don't have anything anymore, but I can take a cube. Let's set the X size to 5 and the Z size to be the same. And I will drop this into a new cloner. And this one will be set to radial. And we just want to bump up the radius. I don't know to what exactly, but let's say about 240. And let's go to the transform and rotate these so that they form a pentagon like this. So these are the 5 sides of our light setup. We can bring this back down to about 140 actually. That should line up edge to edge, or as close as possible. So something like this. And this is what I will then take into this cloner, which we started with. So we used it to clone the main wall section, Now we are just cloning the lights here. Okay. And if I look through this, you can see it is misaligned. This is easy to fix. We just need to go to this cloner at this level and transform the rotation here. I think 18 degrees will give you the correct alignment in this particular case. If you had 6 sides, for example, this would be a different number. So that's the other thing, by the way, you don't have to use a 5-sided shape like this. This could have easily been like a hexagon, for example. So you would have 6 segments here, and then on these clones you would have 5 of these, 6 of these sides rather, which means a slightly higher radius perhaps, and you would need to rotate this by a different amount in order for it to line up, as you can see here. Actually, this would line up by default by itself. All right, but you get the idea. You can basically be more creative with this and do something different. Okay, the only other difference here is instead of having 20 of these, which perfectly line up with whatever we had before, let's have 25. So there will be a slight mismatch in the alignment of the wall section in the lights, and I like that more random look that that gives us. So how do we do the turning certain parts of the lights on and off? This is going to be done using a shader effector. So if I go back to this cloner, and in fact let's solo this whole thing, and again using Magic Solo, one of my favorite plugins ever. It's very, very useful. Okay, and at this level I am going to get a shader effector. So if I bring that in, which by default just scales everything up by 0.5, so let's actually leave that turned on, but the scale should be -1, which is just going to make everything disappear. But now I can go to the shading tab, and under shader, let's load up a noise map, and this is going to control the distribution of, you know, turning these on and off. So you can see right now it's affecting each segment the same. Maybe it's not too obvious right now, so let me bump up the contrast all the way up to 100%, and you can see the arrangement is the same throughout. So we just need to change the space here from texture to world, and now each segment is going to have a different pattern. And the way we animate this to constantly be shifting and changing is by simply animating this seed value here. So at the beginning, if I set a keyframe and then move forward 1 second, in this case that's 30 frames, I will then bump this up by just 1. So this would be the first transformation, just like that. And to repeat this, I'm going to go to the timeline, and let's open the seed keyframing here. And we want to first just change this to step, which means there is no gradual interpolation or even linear. It just goes from one thing to the next one. And then with the keyframes selected, we want to go to the properties over here in the attributes and change this after control from constant to offset repeat. And let's repeat, let's say 10 times, which is more times than we would need to cover this entire animation. So that's all we need here. And as I do that, you will see that an extra keyframe appeared here. This is now going to repeat that same increment in the animation, and it's going to offset, which means it's going to be increasing over time. So if I play this back now, you see this is constantly shifting. But at the end here, we have a slight hitch. I don't know if you caught that. It's very subtle. So we need to cut that frame out. And with looping anyway, the first frame is identical to the last frame in the animation. So in this case, you know, this is my first frame and this is the last frame, which means that this would be repeated every time you arrange the loop in a timeline. So you actually want to get rid of this last frame, which in this case is gonna also help us get rid of that weird glitch. So now this is the result. Maybe not too obvious to see what's going on, but these lights are constantly shifting around. And that's how I did the setup for that effect in the original example. And as far as building the geometry goes, and the actual animation, that's it, of both the lights and the camera. That's all we need to do for that. The next thing is going to be developing the look and style of this, and of course we are going to be using Octane Render. So here I am just loading up my Octane layout, where I have the live window across from the main viewport here, and then I have my Octane settings next to my materials section. The first material we want to create here is the main walls. It's this really intricate detail you see, and this was done using displacement and some materials, some textures rather. So let me show you how you would go about generating these. There is a free piece of software out there called Displacement, and it's very easy to use. So for the first texture type, I'm going to load up this first module here, and if I just move one of these sliders, this is the texture that you get, and you can save this to any location on your hard drive, and this will be an 8K map. So I generated 4 versions of this particular displacement map type. So you want to do the same, just randomly moving the slider to generate a slightly different variant. And then the other one I used was I think the JS Velvet option, which looks different. And I used this one for the bump. So this is a really great tool. It's free, like I said, and it generates this amazing 8K maps that we can use with Octane's excellent displacement features. Okay, so I've already done this, so I don't need to repeat it again. But let me start constructing my material. Before we are going to be able to see the actual material, we need some light. So I will start with that. So shader Octane. And let's turn off the diffusion channel, or the diffuse channel. And in emission, this is where we create the light effect. Let's go to texture emission. And here I am just going to load up the standard Cinema 4D color. And this is going to be the first color, just this kind of blue here. And we can maybe lower this to about 10 or so. I think it's too bright. Let's try surface brightness. And also, we are not actually using any actual illumination here. This is going to be based on reflections. So we are going to turn off illumination. This will also speed up the rendering. So once that's done, I will place this on our light material. Still nothing over here, but that's fine. Let's also make a copy of this cloner. So I will copy this, and this version I will make like an orange-red kind of color, maybe around 7 degrees for the hue slider. And this will be the other color. So the setup for this is the main cloner holds 2 other separate colors like this. And now if I send this to the renderer, this is what we have. So let's just create an Octane Sky, go to the main options and put this power all the way down to 0. So we just see, we reset the illumination by default. You know, we have this ambient illumination, so turn that off basically. And that's how you do that. Okay, so we need something to actually reflect this onto. So if go to materials, this time it's going to be a diffuse glossy material rather, not diffuse, and it's going to be black, and let's have a roughness of 0.05. These boxes are very sensitive, so the smallest numbers here will actually have a very dramatic change. But apply this to the wall section, and now we have this. So hopefully you can now see where this is going. Okay, and the displacement. We go to this and add displacement. And in here, we want to use an image texture node. So let's go to C4D Octane and image texture. And in the files, let's load up our first map. And I'm going to click no to keep it in the original location. You see that nothing, and you see that nothing's changed there. That's because we need to change the projection from UV mapping to cubic. And now we see a difference. Now it's just too tightly packed right now. So let's change the length to be 400% instead, to create these larger blocks. And also there isn't enough resolution right now. So let's open this, go to the displacement options, and the level of details will be set to 4K for now. You could go up to 8K if you want, but I think 4 is actually enough in this example. There's a slight issue here, which is that the displacement is not orienting along the wall panel's geometry correctly. It's not lining up, so we need to move this material from this level to the level of the actual tube geometry itself, and when I do that, it now lines up and follows the orientation of the geometry. But there's also another issue, which is that each section here is identical to the next one. You can see, you know, there's 4 or 5 bars here. That's this section down here, and again in the distance over there. So this is where you would want to generate different variations of the displacement map, so you can have a bit more variation in your scene as well. So what I'm going to do here is first of all, let me just come back in here, and in the index, which is when this is where you control the reflectivity, I will set this to 4, so the reflections here will be stronger. And then now I can go to the displacement, make a copy of that. Just hold Control, left click and drag, and then in here we will load up the second variation, and I will do this 4 times or 3 more times. Each time just loading up a different displacement map. And the way we use this with the scene is I will just have 4 tubes, 1 for each texture. And again, you need to use a number which goes into 20 and give you back a whole number, because if you don't, this would not loop. So we couldn't do this with 3 clones, but 4 goes into 20 5 times. That's a whole number, so I know this is going to loop perfectly. Okay, so that's how we get that extra level of variation. Let's quickly go to our settings, and I'm gonna go to the max samples. Let's bump this up to, let's say, 512. I have a single GTX 1080 Ti, and it should handle this quite well. If I was doing an actual render of this, I would do this overnight, of course, and it shouldn't be too bad. Anyway, I will also change this GI mode to GI none, because again, there is no actual illumination here, just some reflection. So that might give us just a bit of extra speed. And I'm also going to remove the vignetting. This will be in the camera imager settings. We don't need this by default. Okay, let's also add some extra detail to the wall material. I'm going to just make this window larger, and I will store a render buffer so we can do a comparison. So here we go. In the materials here, if I select all of them and then go to the node editor, this will be a bit more useful in this particular instance. So the reason I brought this in here is because I want to use the same bitmap in all 4 materials. So it saves me having to go into each channel and doing it separately. Instead of doing that, I can just take an image texture node, which is right here, and load up our JS Velvet map type, and just plug this into the bump channel of all these 4 materials at once. And let's see what that does. So in our live window, this is the before and this is the after. It just gives us that extra layer of detail. And here's something else you can do. Let's say you want to tile the bump map differently to what it is now, but you don't want to affect the tiling of the displacement map. If you just changed the length and tiling at this level, it would change both at the same time. But you can actually go back to the node editor and do this separately. So this transform section here, you can feed a transform node into that. I can't remember what these sections are called. I think this is a node here, but I don't know what this is. Maybe a port. But anyway, if you get a transform, you can pull this into the transform there. And in this, we can go and lock the aspect ratio, and then also change the scaling using this SX control. So I'm going to do another buffer. Let's stop this one and then store another one, and then just change this to, let's say, 2. So we want to tile this larger than it currently is without affecting the original displacement. Okay, I think I need to resend it to the picture viewer, or the live view rather, for this to update. And when I do that, now if I slide left and right, you can see that the bump map here is tiled larger, and the displacement stays the same. So that's a really great feature in Octane with the node editor. Okay, getting quite close to the end here as far as the Octane look. Of course, we need a material for our character, so I will just copy one of these. But let's disable the displacement. And this one will be more reflective, so I will set the index to 1, which is the most reflective, and then going from 1 to 8, it's progressively more reflective, but 1 is the most reflective. Okay, apply this to our character, which is all the way up here. That will have a cool effect. And I'll copy this light material for the eyes, and to find the geometry, I will just type in eyes, and here we go. So I've already done this before, just replace this here, and there we have it. It just looks a bit more interesting than without the blue eyes. So in the render settings, we want to try and get some of this glowing effect. There's also a fog effect further down in the tunnel, but this was actually done with the standard render, so I'll show you how to do that shortly. But in the Octane settings under camera image, I don't think we need to change much here. You could play with the response and see if you can go with a different look, but I quite like the default in this case. It worked quite well. But in the post tab, let's enable this, and the bloom power, that's how you create the glowing effects like this. And glare works similarly, but it is quite different in its appearance. So if I go to glare power, let's say about 10, you kind of have these streaks instead. So that could be a look you prefer. It's entirely up to you, and you can maybe do a mix of the two somehow. So I'll go with 40 for the bloom power, and I think this is quite good. So I would line this up to render. You know, just go to your render options and, you know, output your frame size and then your location, maybe as an image sequence. And then if you want to do what I did here, where, you know, if we again look at the preview, there's a glowing orange light at the end of the tunnel there. Now, you could theoretically do this in Octane, but at the moment, Octane's fog system really isn't all that great. It's very hard to set up and increases your render time by a ridiculous amount. So what I like to do is I will go as far as I can with Octane, and then anytime I want to do atmospheric effects, I will normally switch to the standard render and then combine the renders in After Effects for the final result. So in this example, I would save as incremental, and I want to switch to the standard render, so which I'm already here. So okay, this should be set to Octane so that I can do the main render, and then when I'm done with that, I then save incremental and then change this to standard. So make sure you do this too. And what I'm going to do is get a light, and let's pause this. We don't need this preview anymore. I'm going to disable the Octane sky. We don't need it anymore. And then these materials, I could just leave them as they are or remove them completely. It doesn't really matter at this stage. But on the light, I will attach the same align to spline tag we put on the character, but call this one align to spline light, and this one will be further down the tunnel. So our character is only 2.5% ahead of the camera. This will be 12.5%, so this will be 12.5 at the beginning, and at the end it's going to be 62.5 instead of 52, which means this light is always going to be further from the camera, and it keeps the same distance going into the tunnel like that. And I will go to the general tab, set my color here. Doesn't really matter, let's go for purple because we can always change this in After Effects anyway. And I don't actually want any illumination from this, so no illumination, but I do want some visible light, and just change that to visible. And in the visibility tab, we want to put the outer distance to something higher. So by default it's 500, let's say 1000 instead. And if I render this, you can now see the haze effect in the distance over there. Let's get another light though and set this intensity to 0, so we can maybe see a bit better what's going on. And we can actually make this stronger if we want. Let's say 2000 instead of 1000, and it just makes the effect stronger. So fine tune this to however you want, and you would just render the frame as it is here. We are only interested in the fog, and just to make sure everything comes out correctly, you could perhaps render a an atmosphere multipass, and that's going to carry the visible light layer. And you would enable multipass and save this to a location on your hard drive. So once you do this along with your main render, you can take both of them into After Effects, and let me show you what that might look like. This is the main render. You can see most of this look is actually achieved in Cinema 4D and Octane because of the glow effects and so on. It looks pretty good outside of Cinema straight away. But I also have on top of this the atmosphere layer from the standard render version, and that's all this is right here. And this was purple to begin with, but or pink rather, but using the hue and saturation slider, I changed it to orange. So you just match this to your scene and pick any color you want, basically. And aside from that, I really didn't do much else on top of this except for just some exaggerated color. So bumping up the saturation by 30%, and then a simple curves adjustment, just playing with some of the toning. And this is all down to preference and whatever your style is. But as far as creating the scene in Cinema 4D with Octane Render, that would be it. So anyway, that's it. That's the end of the tutorial. I'm glad I finally got to record this properly. So I hope you guys learned something new, and I hope you also enjoyed another tutorial by me. Anyway, thanks for watching, and I will see you next time.